Okay, so I have already introduced myself as a TA for the course of solid state physics, whose lecture is delivered by Professor Amol Kumar Das from IIT Kharagpur. My name is Prashant Mishra, and today I will give you the solution, I mean video solution for the assignment 2, which is related with week 2. So, solution. Assignment 2. Assignment 2. What is the course? Solid state physics. Whose lectures are delivered by Professor Amol Kumar Das. So, let us start from the question 1. What is the question number? The question number is the number of lattice points per unit cell in FCC, the face centered cubic lattice. So, you know that the face centered cubic lattice means, the face centered cubic lattice means what? A cubic lattice where there are 8 atoms at 8 corners, right? 8 atoms at 8 corners with face center means each atom at each face. How many faces are there? There are 6 faces. So, 6 faces, you know that these corners atoms are actually shared by the nearby all 8 cubes. So, contribution per cubic cell is only 1 by 8, 1 by 8 and from 8 corner 8 plus from 6 faces. Now, in faces, this atom is half contributed by this cell and half contributed by the upper one cell. Similarly, for this atom, half contributed by this cell and half contributed by this other. That means, the atoms at the faces are only contributed half for each cell. So, 6 atoms into half, 6 points into half. So, this is 3 and this is 1. So, this is 4. So, which option is correct? Which option is correct? You see the question. You see the question. This option D is correct. Option D is correct. Next, question 2. Question 2 is that atomic packing fraction gives the information about what? The number of lattice points per unit cell? No. How much compact the crystal is? B. C. The density of the material of the crystal at room temperature, and number D is number of nearest neighbors of a lattice. Obviously, what is packing fraction? Packing fraction. So, answer 2. What is packing fraction? Let us write it, let us denote it F, or sometimes we can write atomic packing fraction, APP. This is equal to what? It is the volume occupied by the atoms volume occupied by atoms in a cell divided by volume of the cell. So, if 30% is the occupied, that means 70% is free, like this. If 70% is occupied, 30% free. So, obviously, the packing fraction represents what? It represents that the how much compact the crystal is. That is option B. Option B is correct for this. Option B. Option B. Okay. So, option B is correct for the second one. Next, the third question. Okay. Third question, that coordination number is the number of what? Coordination number, that you know, that coordination number is the number of nearest neighbor lattice points for a given lattice point. So, coordination number is the number of nearest. So, it is, there is nothing to discuss in question 3. The solution will be the number of nearest lattice points for a given lattice point. So, for question 3, answer is option C. Answer is option C. The number of nearest lattice points for a given lattice point. Now, question 4. Here it is asked to find the packing fraction for FCC lattice, the packing fraction of FCC lattice. What options are given? 1, 2, 3 and D, none of those. Let us first see one figure for this question, for question number 4, that packing fraction for FCC lattice. Question number 4, see this image. Here FCC lattice, okay, you can see this image. For this FCC, what you see, that the relation between the atomic radius r and the lattice constant a for this cubic type is root 2 a is equal to 4 r. From there you can get r is equal to this, and from this calculation you see that the packing fraction for FCC lattice is only 0.74. So, you now it is very clear to you that here for the question 4, obviously option D will be correct. So, for question 4, the answer will be option D, that is none of those. Then the next question, that is question number 5, the coordination number for the body centered cubic lattice. You have already known that the coordination number is the number of nearest neighbors for a given lattice point, number of nearest neighbors for a given lattice point. So, let us see another image. Let us see another image for this question 5. Here you see the middle one, the cubic structure, the red lattice points at 8 corners with the 1 at the center. So, the coordination number for body centered is what? Body centered means at 8 corners 8 atoms or 8 lattice points, 8 lattice points with 1 at your middle of this, I mean center of the cube. So, you see that yellow one at the middle, I mean at the center of the cube, and 8 neighbors are there which are red or pink, something like this. So, obviously, the coordination number for FCC, I mean for BCC, for body centered it will be 8. So, for question 5, question number 5, the answer will be D, that is 8. That is 8. Next question, the question number 6. Next question is the question number 6. So, let us see the question first. Question number 6. What is the question? The Miller indices of a plane which cuts the intercepts 1a, 3b is to minus 2c along 3 axes a, b, c are the primitive vectors of the unit scalar. These are given 4 options. So, here you see that in 3 axes the portion cuts is 1a, your 3b and minus 2c, 1a, 3b and minus 2c. Okay. So, let the what to find? The Miller indices you have to find. So, come to question number 6. Question number 6. Question number 6 here the portions. Question number 6 your question 6. It is that the in 3 axes the portions cuts are given as 1a is to 3b is to minus 2c, 1a is to 3b is to minus 2c. Let the Miller indices are here HKL, HKL the Miller indices. Okay. So, and if the ABC are the primitive vectors, suppose if ABC are the primitive vectors, then you know that in case of Miller indices ABC are the unit vectors, then 1a is to 3b is to 1a is to 3b is to minus 2c is equal to 1a is to 3b is to minus 2c. This is equal to a by h is to b by k is to c by l. A, B, C are the primitive vectors and H, K, L are the Miller indices. So, what data are given to you? The portions are portions which are from these are the 1a is to 3b is to t. Okay. So, the question you one thing you also note in this question that the Miller indices for the which cuts this for A, B, C are the primitive vectors. Okay. So, simply you eliminate A, B, C, then it is coming your 1 by h is to 1 by k is to 1 by l. This is equal to 1 is to 3 is to minus 2. Then its inverse, that is h is to k is to l is equal to 1 by 1 is to 1 by 3 is to 1 by minus 2. Then multiply all these things with 6 to remove these denominators. This will come 6 is to 2 is to minus 3, 6 is to 2 is to minus 3. Thus, in the Miller indices form, we will write that h, k, l, this will be 6, sorry, no dot, 6 2 and 3 bar, 6 to 3 bar, 6 to 3 bar. So, which option will be correct? If you see your question, you will see that the option D is correct. So, for this question, your option D is correct. Option D will be correct. Option D will be the correct one. Okay. Clear? Option D is the correct for the question number 6. Sorry. Now, come to the next question, number 7. Question number 7. Again, you come to the question. The Miller indices 1 0 0 represents a set of parallel planes which are parallel to. The Miller indices 1 0 0 represents a set of, you know that Miller indices never represent a plane, but it represents a set of parallel plane. I think if you have gone through the lectures of Professor Das, that there he has cleared these things very nicely. So, now here you have to answer that the Miller indices 1 0 0 represent a set of parallel plane, fine, but which are parallel to which axis? Now, let us see if some image I can show you for this also here. Here you see this 100, the sometimes something like the yellow color plane. That yellow color plane, you see that 100 plane, it cuts the x axis at 1 and it is parallel to y axis and z axis. So, obviously, the answer will be obviously for this question the the answer will be it is parallel to your B and C axis. It is parallel to your B and C axis, that means parallel to B and C axis means B option will be correct. So, B option will be correct. Also you can show question 7, question 7's option B will be correct, right? Is it question 7? Let me check once again. Okay, yes, yes, it is question 7. Also you can get a calculation like this. See, when it is parallel to B and C axis and so cuts, so 1 by A is to 1 parallel to B means 1 by infinity, I mean it cuts B axis at infinity, similarly it cuts C axis at infinity. So, like this, so this will be simply 1 is to 0 is to 0. So, the Miller index is 1 0 0. So, question 7 option which option is correct? I told the B option, sorry, not sorry, that is a mistake, B option. So, option B, that is it is parallel to parallel to B and C axis. So, this over. Question 7 over. Now, question number 8. I will come next to the question number 8. So, next let us first see, let us go through the question number 8. Let us understand what is there. The ratio of intercepts on the 3 axis, I mean x, y, z axis by 1, 3, 2 bar planes. 1, 3, 2 bar is the Miller indices of a set of parallel planes, as you know, in a single cubic lattice. So, it is cubic lattice, I mean the primitive vectors A, B, C are equal, that you must remember. So, the primitive vectors A, B, C will be equal because it is the simple cubic type. So, if P, Q, R are the intercepts. So, if P, Q, R are the intercepts, so let this is the question number 8. I am going to solve question number 8. So, let P, Q, R are the intercepts in 3 axis in 3 axis. Let these are the in 3 axis. Okay. So, obviously, as you know that P is to Q is to R, the P is to Q is to R is equal to A by H is to B by K is to C by L. However, for our case A, B, C are equal and the Miller indices are given. What are the Miller indices given? Miller indices 1, 3, 2 bar. So, first, so we will write this is A by 1 is to 3 by B is also is equal to A because it is simple cubic and it is cubic type. So, this is 1 3 and this is also A by 2 bar means minus 2. So, P is to Q is to R, this will be this. So, this is equal to 1 by 1 is to 1 by 3 is to 1 by minus 2. So, let us multiply whole things with 6, then 6 is to 2 is to minus 3. So, 6 is to 2 is to minus 3. So, 6 is to 2 is to minus 3 means option B is correct. So, for question number 8, option B is correct. Option B is the correct answer, 6 to minus 3. Okay. So, next question, the question number 9. Oh, I have removed the heading, that assignment 2. Oh, no issue, already it is recorded. Now, come to the question number 9. The primitive vectors in a crystal, the primitive vectors in a crystal are, the primitive vectors in the crystal are your 1.2 angstrom, B is 1.5 and C is 1.8 angstrom. A plane 2, 3, 1, which is nothing but the Miller indices, cuts an intercept 1.2 on the x axis, find the corresponding intercepts on y and z axis. So, it is similar to the previous one question, just in a different mode it has been thrown. So, again we will write P is to Q is to R. So, question 9, again we will write P is to Q is to R is equal to your well known formula A by H is to B by K is to C by L, is to C by L. A by H is to B by K is to C by L. Now, the values of A, B, C are values of A, B, C are given here. Question number 9, A is 1.2 angstrom, 1.5 and C is 1. So, what are the values given? A is equal to 1.5. Let me see the question. A is given 1.2 angstrom, 1.2 angstrom, and B is your 1.5 angstrom, and C is given your 1.8 angstrom. Okay. And the Miller indices, no, find the corresponding, the 1.2 angstrom. The Miller indices is what? HKL, it is also given. This is equal to given your 2, 3, 1. These are the data supplied, and also one more data is supplied, that it cuts the intercept 1.2 angstrom on x axis, 1.2 angstrom. That means what? That is P is equal to 1.2 angstrom. That is P is 1.2 angstrom. So, again like the previous problem, we can proceed this way, that P, this is equal to 1.2 by H, H is what? 2, and B is given 1.5, this by K is 3, is to C, okay, C is 1.8, this is by L is 1. So, you getting here, you getting, let us separate this data. So, it is 0.6 is to 0.5 is to 1.8. Now, this P Q R. So, we can write P by Q is equal to 0.6 by 0.5, that is your 6 by 5, and or otherwise you can write Q by P, this is equal to 5 by 6. So, Q is equal to 5 by 6 into P, and fortunately the value of P is given 1.2 angstrom. So, you put 5 by 6 into 1.2, this will be 6 by 6, that is 1. So, Q we getting Q is 1 angstrom, we getting Q 1 angstrom, and similarly if you proceed this way, you can write Q by R. Q by R is equal to, you can write from the here 5 by 1.8, 5 by 1.8, or just in the inverse way, R by Q is equal to 1.8 by 5, that gives R is equal to 1.8 by 5 into your Q. Q is already obtained, which is 1. So, sorry, okay, 0.5. Here it is 0.5. Sorry, this is 0.5. Yeah, it is 0.5. So it is divided by 0.5. So this q is already obtained 1. So it is 1.8 by 0.5. So 3 and 3.6. So your answer will come that C option, that q is 1 point. So solutions is answer will be C, that is q is equal to 1 angstrom and r is equal to 3.6 angstrom. R is equal to 3.6 angstrom. Okay. So question 9's solution is complete. The next one, the 10th question. Actually, the questions are arranged in such a way that if you go through the video, all these videos very carefully, then you will get almost all the questions directly from there. And for some questions, you may have to follow some books, but basically the arrangement of the questions actually are almost from the videos delivered by Professor Das. So, I will advise you that before submission of your answer, you must go through the videos carefully. Now, question number 10. Question number 10. Question 10. Let us see what is the question number 10. That the Miller indices for the given shape. The shape is shown, Miller indices for the given shape. Okay, so this is very simple question. Let me remove this. Let me remove this also, and I will try to show you another one image for this question 10. See the image. This YOLO. Okay, so it cuts x axis at 1, y axis at 1 and parallel to z axis. X axis at 1, y axis at 1 and parallel to z axis. So, also the solution I have shown 1 by 1, 1 by 1, 1 by infinity, this is 1 0 0. So, this is very simple, and I think from this image it will be more clear to you that the Miller indices for this given is 1 0 0, that is option D. So, answer will be option D. Answer is option D. Okay. Then come to the question next, question number 11. Question number 11. What is the question? The relation between atomic radius and the lattice constant A in case of simple cubic structure. This is a very simple question. Okay. Now, question number 11, let us write in heading the question number 11, otherwise there will be confusion. Question 11, the relation between lattice constant A and atomic radius for the simple cubic. Here we assume the atoms like this. Okay. So, from here to here, this is A, again the radius of the atom R. So, 2 R is equal to A will be the answer, or A is equal to R by 2, or A is equal to R by 2. So, question 11, which option will be correct? A is equal to R by A is equal to 2 R, or sorry, R is equal to A by 2. R is equal to A by 2. A is equal to twice R, or R is equal to A by 2. A is equal to twice R, or R is equal to A by R is equal to A by 2. So, option A is correct. Option A will be the correct answer. Option A will be the correct answer. A is equal to twice R. Next, question number 12. Some of you may think that almost all the questions are simple. Actually, matter is that gradually we will gradually what we will do, that we will give the more and more complicated question, but always we will keep in mind that at least 70% questions will be for the common students and some 30% may be for special type of students. Okay. Now, we will come to the question number 12. Question number 12. Question number 12, the diamond lattice can be considered as a combination of two FCC lattices along the body diagonal by 1/4 of its length. There are 8 atoms per unit cell, the packing fraction of the diamond. Okay, fine. Come to another one image, the diamond structure. See this diamond structure. Okay. This is the structure of diamond. Okay. So, you see that the diagonal, the body diagonal 8R, because inside it is 3 atoms. So, 6R and contribution at the corners 2R. So, 8R is equal to root 3A. A is the lattice constant, I mean the primitive vectors A. And another point you must see from this, that here the number of atoms per unit cell is 8. Okay. So, first of all root 3A is equal to 8R and number of atoms per unit cell is 8. So, then you can calculate easily. Then you can calculate it easily that your root 3 A is equal to 8R. So, which question number? Question number 12, root 3 A is equal to 8R. R is the radius of the atom and A is the primitive vector. And coordination number, your number of atoms per cell is 8. Then atomic packing fraction, you write this way, atomic packing fraction, sometimes it is written small f. So, you know this is the volume of the atoms occupied by the cell, occupied in the cell, and the divided the volume of the cell. So, 8 into 4/3 pi r cube, this is the volume occupied by the atoms divided by A cube, which is the volume of the cell. And here is the relation, A is equal to 8 by root 3. So, this will give you 32 pi r cube by 3 A cube. A is what? A is 8 by root 3. A is equal to 8 by root 3 into r. 8 by root 3 into r. So, r cube. So, this way r will be eliminating, and then you getting 32 pi by 3 into this is 8 into 8 into 8, and this way if you calculate simply just by calculation, you will get the answer, it will be 0.34 only. So, note that atomic packing fraction is low in this case. Only 0.34. So, for this question number 12, option C, yes, option C 0.34. Option C is correct. Option C is correct. Option C is correct. Next, what? Question number 13 is the question number 13. The fraction of volume occupied in the unit cell for the body center cubic lattice. Body center, a body center cubic lattice. The body center means what? That there are 8 lattice points at 8 corners with 1 at the center. So, again I hope I can show you another one image for the body center. Yes, yeah, for the body center cubic lattice. See this image. Atomic cracking we have calculated. Here it is calculated in different way, but our answer in the different mode. I will come to that point. So, first you check that for the body center, what is the relation between A and R? It is root 3A is equal to 4R. One point, root 3A is equal to 4R, and second point, for the body center cubic, number of lattice point per cell is obviously it is 2, 1 from the 8 corners and 1 at the center. So, let us forget about that numerical value, we will come to that actual which will match with our expression. So, only the two informations are there, root 3A is equal to 4R. So, come root 3A is equal to 4R and number of lattice points per cell, points per cell is equal to 2, 1 from 8 corners and 1 at the center. So, now let us calculate how to find atomic packing fraction. Oh, which question? Now, let me note the question number first to avoid a mistake. Question number 13. Question number 13, atomic packing fraction. So, 2 into 4/3 pi r cube by a cube, and answer is given in okay. So, now this is equal to your 8 pi r cube by 3 into a cube. A is what? 4 by root 3 r. Okay, let us write smaller, 4 by root 3 r, this whole cube. So, this will be 8 pi r cube will be eliminating 3 into it is 64 by 3 root 3. So, this 3 again eliminating. So, then it is coming 8 root 3 pi by 64, 8 root 3 pi by 64, though then root 3 pi by 8. Okay. So, this is the fraction of the volume occupied. Okay. So, occupied volume is root 3 pi by 8, then unoccupied volume is how much? The total volume is 1. In terms of fraction, total volume is 1 minus root 3 pi by 8, then you see 8 minus root 3 pi by 8, 8 minus root 3 pi by 8. So, which option is coming correct? Option A, 8 minus root 3 pi by 8. So, your for this question number 13, option A is correct. Option A is correct one. Option A is correct. So, this is over. Now, the last question, it is the last for this assignment. assignment to the last question, question number 14. Question number 14 of the assignment to the last question. Question 14. This is the assignment to the last question. The interplanar spacing. Okay, let us see the question. Come to this question. Interplanar spacing for 1, 0, 0 planes in a simple cubic lattice having lattice constant 4.2. Note, the mirror indices is 1, 1, 0, HKL value is 1, 1, 0, and it is the simple cubic. So, all the sides are same. I mean lattice primitive vectors ABC are equal here. The value also given 4.2, and you know that interplanar spacing for this is simple, very simple. D is equal to 1 by your A by for this simple cubic H square plus K square plus L square. So, what are the values of HKL given? We may check again what are the values of HKL values are given. Yeah, this is 1, 0, 0 and A is given 4.2. So, now it is 4.2 by 1, 0, 0. So, 1 square plus 1 square plus 0 square. So, this is 4.2 by your root 2. 4.2 by root 2, that is your 2.1 root 2. You can calculate 2.1 into 1.414. This will be 828. So, 2.828. This is nearly is equal to 3 angstrom, and we have already discussed that when your result will be not in a complete integer value, but nearest to the correct one, you obviously choose the that value. I mean, if the value is coming 2.9 and you getting the option, suppose you getting after calculation 2.9, one option is 3 and one option is 3.5. So, obviously, you will choose the nearest one, that is 3. So, this way here option will be 3 angstrom, that means option C is correct. So, all these questions are discussed. Thank you very much and for your attention, and hope this will help you to clear your queries, and till the doubts are there, you must ask question at forum, and we, our team or Professor Das, will try to clarify your queries again and again. Thank you very much. Okay, we will meet in another day.